So we have this equation, 2x plus 2y plus 2z equals 12. X plus 2y plus z equals 3. Z equals 8. Okay. Now I want you guys use the Gaussian elimination method. Use the matrix form. So the first step, you need to write down the augmented form of the this 3x3 equation system, right? The strategy is gonna be very straightforward. Always keep the diagonal elements equals 1. Okay, keep the diagonal element equals 1. Let's see. Use the first equation to eliminate the first variable. Use the second equation to eliminate the second variable, right? Did you get the solution? What's the solution? X equals 1 or -1. Should be a -1. Yeah. You can plug in the 1 here. So if here is 1, y is -3, -6, -5, -5. Oh,
Yes, I have one -3. Yeah.
let me check. Also 1, -6. You're right. You're right. Makes sense. I think you're right. So -1 plus -3. Okay. You're right. It's 1.
Yeah, but I plugged it back in and
Because it's the right answer. Yeah, you're right. Okay, I'm gonna show you the answer. The first thing you need to write down the augmented matrix. That is 2, 2, 2, 12, 1, 2, 1, 3, 0, 0, 1, 8. Right? That's the augmented matrix. 1, 8. Because the z coefficient z equals 1. So now you can see the diagonal element, that is 2. We want to keep the diagonal element equals 1. That's the principle of Gaussian elimination. So we want the first row divided by 2. Right? And we're gonna get what? 1, 1, 1, 6. 1, 2, 1, 3. 0, 0, 1, 8. Okay. Now we always want to use the first equation to eliminate the first variables. What are we gonna do? We're gonna let R2 subtract R1. And for the R3, we already get 0. So it's not necessary to do anything for the R3. So three minus 6. Right? That's it. Because if we want to use the second equation to eliminate the second variable y, here already 0. So we do not need to eliminate anything, right? So that's it. We just keep it. Now we're gonna have solution. We have the equation x, or you can write that this way: x plus y plus z equals 6. Y equals -3. Z equals 8, right? And then use back substitution we learned before. Back substitution. We have what? We plug in back, we get -3 plus 8 equals 6. And we can get x equals 1. So the solution set should be 1, -3, 8. That's it. That's it. Okay. Now, today we're going to learn a new method we called Gaussian-Jordan elimination. Gaussian-Jordan elimination. We still take on this guy as an example. So previously, what did it do? The Gaussian elimination. Okay, we already did the Gaussian elimination for this matrix, and we boils down to the this matrix. And I'm gonna write down this matrix. Right, and the goal of this guy is 1116 1010 negative 3 and 0018. We already did the Gaussian elimination for this matrix, right? And we got this guy. Now we're gonna do the Jordan elimination. How to do it? We want, eliminate the element above the diagonal equals 0. That's our goal. For the Gaussian elimination, our goal is what? Our goal is the element below this diagonal equals 0, and we keep the diagonal element equals 1. Okay, so that's the basic idea for the Gaussian elimination. That's the reason why we need to keep the diagonal element equals 1. So keep the diagonal elements equals 1 and keep the elements below the diagonal equals 0. That's the Gaussian elimination. Very similar. For the Jordan elimination, we already got this up triangular, right? Because a bunch of 0 below the diagonal. We want the element above this diagonal equals 0. Okay, so basically this part equals 0. Okay, so how to eliminate this guy? Eliminate this element. So the first row, subtract second row. You understand? Here's a 1. Here's a 1. We'll just do the subtraction, right? Subtraction. So 1, 1. Here's a 0. 1 minus 0 is 1. 6 minus is 9. Copy it. Okay, we eliminate this element. Okay, equals 0. Now, we wanted to eliminate this guy too, right? Because this guy is non-zero. What are we gonna do? What are we gonna do? How to eliminate this guy? Good job. That's it. Row 1, subtract row 3. So we have 1, 0, 0, 1. That's it. Now, you can write down everything. X equals to 1, y equals -3, z equals 8. The miracle happens. You can tell through the Gaussian-Jordan elimination will directly give you the solution of this one. Right? Previously, we still needed to do the back substitution after Gaussian elimination. Right? However, when you do the Gaussian-Jordan elimination, you can directly get the solution. That's the advantage for the Gaussian-Jordan elimination. Okay. Understood? Very good. So now I'm gonna give you guys an example. Let you guys try it. Okay. Let's try this one. Um, negative x, -1. Oh, try this one for me. 7, yes. So use Gauss-Jordan elimination. Gauss-Jordan elimination. Okay. So the first thing you're gonna do the Gauss elimination, then you're gonna do the Jordan elimination. You get it?
17, negative 3.
17, negative 3, 8. That's wrong. 17, negative 17, 8, 3. No. You can plug it in here. 17, negative 17 plus 8 is negative 9. It's not right. So plug in the 17, negative 17 plus 9 should be plus 8, right? Equals negative 9. Not the same. It's clearly you make a mistake. Okay, I'm gonna do it on board. So let's do it. The first step, we're gonna write down the right. Basically, we have the augmented matrix of this guy. Now we always want to keep the diagonal equals 1, right? For this guy, we just divide by 1/3. Right? And we have divide by 1/3. And this guy will be now we want to use the first equation to eliminate the first variables. These two. We want to keep these two equals 0. Right? That's the purpose. So let's take a look. R2 minus 2R1 for the R2. Because here's a 2, here's a 1. Subtract 2 times R1. Now R3 plus R1 for the R3. Okay. And for the subtraction, you multiply what? 2. So we're gonna do the subtraction for the second row. 2 subtract 2, 0. 4 subtract 2, 0, 6, negative 6. Okay, that's the second step. And for the third row, gonna be addition. Negative 1, 0, 1, 2, 3. Right? 0, 2, 13. Okay, so we eliminate these two elements. Now again, goes to diagonal. Diagonal here is a 2, right? So we want to keep the diagonal equals 1. Right? Now we want to use the second equation to eliminate the second variable. So we're gonna have R3 subtract R2 for R3. Okay, and again, you have diagonal element that is 2. We want to keep this guy equals 1. Oh, sorry, equals 1. So we have Okay. Now we finish Gaussian elimination, right? Now we're gonna do the Jordan elimination. For the Jordan elimination, we wanna keep the diagonal, the elements above the diagonal equals 0. So we wanna keep this guy 0, 0. And of course, we wanna keep this guy 0. It's here already 0, so we don't need to care. What we're gonna do is, let R1 minus R2 for the R1. So it's 1, 0, 1, 6 minus 3, 9. Okay, and again, we want to keep this guy equals 0. What does that mean? We let R1 subtract R3. So we're going to get x equals 1, y equals -3, z equals 8. Okay, we have the solution is 1, -3, 8. That's it.
I think R2 minus R1 and R3 minus R1. I thought you had to use the second and third row.
This one?
For both of them, for the second method. At the first time, I did R2 minus R1 to get a new R1.
R1 minus R2. You need to use this equation to eliminate, or use this equation to eliminate this guy.
Oh, okay.
Yeah, because we keep the R2 the same. We want to use the second equation to eliminate the first equation. It's a kind of reverse process. So from the Gaussian elimination, you use the first equation to eliminate the first variable or the second equation, right? And for the Jordan elimination, you're gonna use the second equation to eliminate second variable in the first equation, and use the third equation to eliminate the third variable. So you always keep the second and third the same, okay? Any other questions? Huh? Jordan method, yeah. First one is Gaussian elimination. So we're gonna boil it down to here. That is Gaussian elimination. And then we wanna keep the element above the diagonal equals 0. That is Jordan elimination. So the total we called Gaussian-Jordan elimination. So the first step, you do the Gaussian elimination. Then after you get the up triangular, that means all the elements below the diagonal equals 0. Then you're going to do the Jordan elimination. Jordan elimination, the goal of the Jordan elimination should be the elements above the diagonal equals 0. Okay? Clear? So we have different goal. For the Gaussian elimination, we keep the elements below the diagonal equals 0. For the Jordan elimination, we keep the element above the diagonal equals 0. Okay, I'm gonna give you guys another example. Let you guys try it again. Okay, so I gave you this equation that is 3 by 2 by 3 matrix, 2 by 3 matrix, or 2 by 3 equation. Now, here I can tell you we have infinity solutions because 3 unknowns. Suppose we have 3 equations. However, I give you 2 equations. That means we have infinity solution. Okay, and the goal of this guy should be we have 2 elements. That is 1, 1, and we keep the element below the diagonal and above the diagonal equals 0, and we have elements here, right? Whatever element here. That's our goal. Okay, we want to use Gauss-Jordan elimination to get what? Get like that. That's our goal, right? That's our goal. Can you try it? So that's the diagonal, and we get a 0 below the diagonal and a 0 above the diagonal, right? That's our goal. Okay, as long as you get this one, everything will be easy, I think. Okay, I'm gonna write down the answer on board. Um, So for this guy, we can write down the augmented matrix. Right, augmented matrix. So since this guy is 2, right? We always want to keep the diagonal element equals 1. So we have right, and then we want to eliminate this guy, right? Use the first equation. So 3 R2 minus 3 times R1, okay? And 3 is 6, 3, 6, 3, 0. And this guy will boils down to 3 minus 3 is 0, negative 1, 3, and 1. Right? And of course, we want to keep the diagonal element as positive 1. So we have times negative for the R2. Negative 1, negative 3, negative 1. Okay, so we finish the Gaussian elimination. That is this guy. We keep the element below the diagonal as 0. We keep the diagonal elements equals 1, right? We finish the Gaussian elimination. Okay, now we want to do the Jordan elimination. That means I want to keep this guy equals 0, right? What are we going to do? We let R1 subtract 2R2 for the R1, right? So let this guy has 2. Let this guy has 2 going to be this guy. And then we do the subtraction. 2 minus 2 is 0. Going to be a negative 5, 2. Oh, sorry. So it should be positive 5. Negative 1 subtract negative 6. Going to be a plus 6. Positive 2. Okay, we finish the Jordan elimination because we keep the element above the diagonal equals 0. Right? Very simple. Now you can write down the equation. X1 plus 5x3 equals 2. And x2 minus 3 times x3 equals negative 1. Okay, so now we can write down as use x3 to express the other 2 variables. It's very clearly we can use parametric representation to express the solution, right? So we let x3 equals t, for example. So the solution gonna be x1 x2, x3. That's it. Okay, we have the solution that equals x1 equals 2 minus 5t, and x2 equals -1 plus 3t. X3 equals t. Okay, x3 equals t. Any questions so far? No question. I'm gonna give you guys another example. Let you guys practice again. Try this one for me, okay? You get it?
Yeah.
You-
Yeah. X one t equal to 3x. The third.
So x1 equals what? x1 equals -2t, right? 2t. 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 2 x2 equals to x3 equals to, how about you, Qifang? Yeah. X2 equals whatever variable, x3 whatever variable. You got it. Okay. So I'm gonna show you on the board. Augmented matrix. So we're gonna, here it's already 1. We don't need to care about the first equation because diagonal element is already 1, right? So for second equation, we're gonna eliminate this guy to 0. We have R2. So we have 2, -2, 6, 0. Subtract it. Should be 0, 2. Sorry, 3. 1 minus -2 should be 3. -3, 0. Okay. And again, since this diagonal is 3, we want to keep this guy as 1. So we just let this guy divided by 3. Right? And we're gonna get 1, -1, 3, 0, -1, 0. Right? Now we finish the Gaussian elimination. We keep the element below the diagonal equals 0. We keep the diagonal elements equals 1, right? That's the purpose of Gaussian elimination. Very good. Now we're going to do the Jordan elimination. Jordan elimination, that means we let the element above the diagonal equals 0. So we want to keep this guy equals 0. That means what? That means we let the R1 plus R2 for the R1. Okay, I'll write down over here. We let R1 plus R3 for the R1, right? Because here is -1. We want -1 plus 1 should be 0. Right? And then you can write down the equations. And of course, you can write that as right. You can write down as okay, very good. Now we let x3 equals t and x1 -2t, x2 equals t. That's it. That's the solution. Okay. I'm gonna wrap it up class here. Okay, I've finished. Today I just finished the Gauss-Jordan elimination. When you go back home, practice the problems. Practice the problem, especially for the Gaussian elimination. That's super important. We're gonna use a lot Gaussian elimination in later sections. Okay, that's it. Have a nice day. Keep it healthy.